So today we're going to be working more with trig identities, specifically this time verifying trig identities. So what we're going to have on these is an equation, and we've got to verify that one side of the equation equals the other side of the equation by using our identities to manipulate and change one side to where it looks like the other. So some steps right here. So, again, this is kind of an ambiguous process. It's not really a set step-by-step way of doing things, but these are, ideas, things you can look for. So first, always work with the most complicated side of the equation first. Try to change the more complicated side into the simplest side. Second, you need to look for the following opportunities. So these are things to look for. Look to factor an expression. A lot of times that can help you. If you have multiple fractions on the complicated side, add those together if you can. Square binomial. Right, so if you've got parentheses with something, two things in it, and that's being squared, square that out to get rid of the parentheses, and create a monomial denominator. What that means is if you have a denominator that has 2 or 3 terms, try to manipulate the bottom of that fraction to change it to where it's just one term. Right, and a lot of times from there you can split it up into different fractions and simplify, get rid of the fractions from there. So next, look to use the fundamental identities. Okay, so that's your Pythagorean identities, your reciprocal identities, quotient identities, those real basic ones. And then number 4, whenever these don't work, try to convert everything to sines and cosines. So if you have a tangent, a secant, cosecant, cotangent, change all those into sines and cosines using the reciprocal identities or the quotient identities. And a lot of times that can help you simplify things down. But always try something, okay? There's going to be times you're going to get to a dead end and you need to go back and try something else, okay? That's going to happen on these, so just try not to get too frustrated. It's kind of like a maze. You try one way, you run into a dead end, you got to go back and try another way. And, you just got to keep going until you solve the maze. All right, so first of all, let's look at one of these. So this first one, so it says verify the identity. And part of this got left off. That's supposed to equal sine squared theta. So let me just write that in there. This is supposed to equal sine squared theta. Got a mistake already right off the bat. All right, so we want to verify that that left side equals the right side. So again, we're going to start with the most complicated side first. That's the side on the left. And we're going to try to change it to look like sine squared theta. So we see secant squared. That's a clue that we can use a Pythagorean identity. When you start seeing secant squareds and cosine squareds, all those things, and Pythagorean identities a lot of times will come in handy. So a Pythagorean identity tells us that secant squared is equal to tangent squared plus 1. So let's change that top to tangent squared plus 1 instead of secant squared. Let me put my theta in there. And then minus 1 over secant squared theta. Alright, so the plus 1 and minus 1 are going to cancel, and we just have tangent squared theta over secant squared theta. Okay, now we've got just one fraction, so when you get down to something like this, that's, there's no sines and cosines, but you've got the other trig functions. If you change to sines and cosines, then a lot of times it will help things cancel out, simplify, and things will be a little bit cleaner. So we want to try to make it look like sine, right? So we want to get rid of this fraction. So let's change tangent into sine squared theta over cosine squared theta. That's a quotient identity, that tangent equals sine over cosine. So tangent squared is going to equal sine squared over cosine squared. And then secant squared is 1 over cosine squared theta. That's one of our reciprocal identities. So now we've got a fraction divided by a fraction. When we have a fraction divided by a fraction, we keep the first fraction the same, we change it to times, and we flip the second fraction. So that's 3 over 1. Alright, so once we flip the second fraction, now we can multiply. So we get cosine squared times sine squared on top. On the bottom, we just have cosine squared theta. So then those cosine squared thetas cancel, and we're just left with sine squared theta. So we now change that left side to equal sine squared theta. Of course, the right side is still sine squared theta. So we verified that left side equals the right side. All right, let's do another one. So on this one, the most complicated side is the right side. I'm going to erase all this to give some more room. So we'll start with the right side and try to change it into the left side. So one of our things that we can try when we have fractions is to combine our fractions, add fractions together. So to add these, they need to have a common denominator. Well, one denominator is 1 minus sine of alpha, and the other one's 1 plus sine alpha. Okay, yeah, that's another Greek letter alpha that you'll see used sometimes instead of theta. So we're going to multiply both fractions by the denominator on the other fraction. So for example, right here we need to multiply by 1 minus sine alpha, and up top 1 minus sine alpha. And then on the left fraction, we need to multiply it by 1 plus sine alpha, and the top by 1 plus sine alpha. So now on the top fraction, we've got 1 plus sine alpha times 1 is 1 plus sine alpha. On the bottom, we have 1 plus sine alpha times 1 minus sine alpha. And then on the other fraction, 1 times 1 minus sine alpha is just 1 minus sine alpha. On the bottom, we have the same denominator, 1 plus sine alpha times 1 minus sine alpha. Alright, so let's multiply those denominators, actually like full amount. Whenever you FOIL those, of course the top's still 1 plus sine alpha. Whenever we FOIL the bottom, 1 times 1 is 1. Sine alpha and minus sine alpha is going to give us minus sine squared of alpha. And then, of course, 1 times minus sine and 1 times positive sine, well, those are just going to cancel out. So I don't need to put anything else in the denominator. Then the other ones, of course, going to be the same thing, because that was the whole point, is to get my denominators the same. All right, now I can add the fractions because they have a common denominator. So I'm going to add the numerators. So at the top I have 1 plus sine alpha plus 1 minus sine of alpha over 1 minus sine squared alpha. Alright, and then up top we got sine alpha and minus sine alpha that cancel out. 1 plus 1 is 2. And then on the bottom I have 1 minus sine squared. Okay, so 1 minus sine squared, using the Pythagorean identity that sine squared plus cosine squared equals 1, I can change 1 minus sine squared into cosine squared alpha. Right? And then, again, the whole point, remember, is to get it to look like this, 2 secant squared alpha. So then we use the reciprocal identity. 1 over cosine squared is secant squared. So then I can change this to 2 secant squared alpha. Because if cosine squared is on the bottom, that's the same as secant squared being on the top. Alright, so now I've confirmed that the right side is the same as 2 secant squared alpha, and my identity is verified. Alright, so go ahead and pause the video, try this one down here. And notice you have 2 different fractions, so you need to give them the denominator from the other fraction to make sure that they have common denominators. Of course, you got to give that to the numerator, and look for stuff to cancel out and see if you can make this left side equal 0. So right here we need to multiply the denominators and the numerators of each fraction by the denominator on the other fraction. So notice I take cosine x plus cosine y, and I multiply both the numerator and denominator by that on the other fraction. And likewise, I'll take sine x plus sine y, and I multiply the denominator and numerator by that on the second fraction. Okay, so up top, when I do cosine x plus cosine y times cosine x minus cosine y, well, I'm multiplying conjugates, so we know the middle terms are just going to cancel. So I do cosine x times cosine x, cosine squared, cosine y times cosine y is cosine squared y, and of course it's a minus because it's positive. Cosine y times negative cosine y. So the numerator is now cosine squared x minus cosine squared y. Same thing happens to the top of the other fraction, but with sines. So it's sine x minus sine y times sine x plus sine y. So sine x is multiplying, give you sine squared x. The positive sine y minus sine y give you minus sine squared y. Then in the denominators, I've got just cosine x plus cosine y times sine x plus sine y. I put that in both denominators. Alright, now next I can add the fractions because the denominators are the same. I'm not going to spend the time to multiply and FOIL everything in the denominators on this one because you'll see why here in a second. So I add the numerators. That gives me, I I'm adding sine squared and cosine squared. Okay, so this is important to notice that when I add these two numerators, I've got a cosine squared and a sine squared. So I'm going to put those together right here. And then I've got a minus cosine squared and a minus sine squared. So I put those together. All right. And then I know from a trig identity that sine squared plus cosine squared is 1. So that's where this 1 came from. All right. And then on the other, the minus sine squared minus cosine squared, I take out a negative, as you can see right here. And that leaves positive sine squared y plus cosine squared y. I'm going to take a negative from both of them. And then I use my Pythagorean identity again. Sine squared y plus cosine squared y is 1. So up top now I have 1 minus 1 because this became 1 also. So it became 1 minus 1, which is just 0, right? And I've got a little squiggle down here. I'm not going to write all that stuff out again, but that's what would be on the bottom. So I'd have 1 minus 1 over the cosine x plus cosine y times sine x plus sine y. And then 1 minus 1 up top is 0. So I'd have 0 over all of that stuff. And then 0 divided by anything is 0. So I've confirmed that left side of the fraction is just going to simplify to 0 because the numerator is going to become 0. And so that's going to simplify out to 0. All right. So let's do some more. All right. So this next one, we got to verify the identity. So let's pick out which side's the most complicated. On this one, definitely the left side is what looks to be the most complicated side. So we see we got tangent squareds and cosine squareds with 1s. So those are clues to use some of your Pythagorean identities. We know tangent squared plus 1 is secant squared, so we can change that to secant squared x. And we know normally we would say that we have the sine squared plus cosine squared identity equals 1, right? So if you subtracted cosine squared, we would see that sine squared equals 1 minus cosine squared. All right, but that's not what this says. This says cosine squared minus 1. Okay, whenever you have something that looks like it fits your identity, but the terms have been swapped, so, you know, it's like instead of 1 minus cosine squared, it's cosine squared minus 1, then all you can still use the identity and substitute sine squared, right? But you've got to remember to just put a negative in, okay? Because a negative, if I multiply this right side over here by a negative, it would make the 1 a negative 1. It would make the cosine squared positive. All right, and so that's negative 1 plus cosine squared is the same as cosine squared minus 1. So multiplying by a negative will make your identity, you know, fit the rule that we use, right? So that makes that secant squared x times sine squared x equals negative tangent squared x. All right, so now we need to try to convert this to make it look like tangent. Well, secant, using our reciprocal identity, is really 1 over cosine squared x. Now we're multiplied by sine squared, so the sine squared is going to go up top, so I have negative sine squared x over cosine squared x. And then sine squared x over cosine squared, we use the quotient identity. Tangent is sine over cosine, so we can change that to be tangent squared x. So now I've confirmed that the side equals negative tangent squared x. And that's kind of a good way to do it, is to just continue that right side all the way down, change all the stuff on the left side like I did, to where at the end you get one thing equals another. You can just say, all right, check mark, I got it. All right, let's do another one. So B part over here, tangent x plus cotangent x equals secant x times cosecant x. All right, so notice that on the left side you're adding things, but on the right side they're multiplied together. So that's a hint that you need to figure out a way to combine those two terms together, the tangent x and the cotangent x. Okay, so let's use that side, and what we'll do is convert those into fractions, all right, so we can add the fractions together. So using tangent x, tangent is sine x over cosine x, whereas cotangent is the exact opposite, cosine x over sine x. So we're going to change, now we're going to take those two fractions and try to add them together. All right. So again, the whole reason we're doing this is because it looks like over here there's nothing added together, right? It's multiplied. So we need to convert the thing on the left to be just one term. So we need to find a way to combine tangent x and cotangent of x. And we can't do that if we leave it just like they are, because you can't just add those two together. So we've got to figure out a way to add them. So we make them into fractions with common denominators, and we can add them together. So the denominator here is cosine, so we need to multiply it by sine, because that's the denominator of the other fraction. Multiply the other numerator by sine. And then this denominator gets multiplied by cosine of x, and the numerator, of course, by cosine of x. So now the left fraction is sine squared of x over sine x cosine x. And then the second fraction is cosine squared x over sine x cosine x. Okay, and then remember, we're always remembering out here to the right, we've still got our secant x, cosecant x, that we're trying to make it equal, right? Secant x, cosecant x. Sorry, run out of room. So now we can add the fractions. So add the numerator, sine squared x plus cosine squared x over sine x cosine x equals secant x cosecant x. Now sine squared plus cosine squared, that's our Pythagorean identity, that equals 1. So we've got 1 over sine x cosine x equals secant x cosecant x. And then we use the reciprocal identity. 1 over sine is cosecant x, and 1 over cosine is secant x. Alright? And you say, well, those look the same, but you flipped them. Well, it doesn't matter. Multiplication, it doesn't matter if you do 5 times 4 or 4 times 5. It's the same way. So if you want to change them around, you can. You don't have to. I would be fine if you left it like that, because it's kind of understood that multiplication is commutative. You can change them around. It's not going to change the answer. All right, so there you can see we've shown that left side equals the right side. Just had to use reciprocal identities and then add your fractions and use Pythagorean identity, and then go back and use the reciprocal identities to change it back to secants and cosecants. All right, so give this one a try and see if you can get that left side to look like the right side. Change to cosecant. Okay, this was pretty straightforward. We just changed the cotangent and tangent to be in terms of sine and cosine. So cotangent, we changed to cosine over sine. As you can see right here, we just changed cotangent to cosine over sine. And then we changed tangent over here to be sine over cosine. So you can see where we changed those two. The bottom's still just sine of x. Okay, so then when we multiply cosine over sine times sine over cosine, the sines and the cosines just cancel out. So we're left with 1. Okay, something divided. On top we have sine times cosine. On the bottom we have sine times cosine. So we really got something divided by itself, which is just 1. So we've got 1, and then we still got the sine of x on the very bottom. And 1 over sine using reciprocal identity changes it to cosecant. So we've shown that the left side equals cosecant. All right, let's do some more. So these are things you got to practice. The more you practice, the the better you're going to get at them, and the easier they're going to become. So you just got to keep doing them, keep practicing using the different identities and figuring out how to go from one thing to the next. All right, so on this one, we see we've got a fraction on the right side. So it's a little bit more complicated. So we'll start with that side. And a lot of times when you've got a fraction on one side and not on the other, a good strategy to use is to multiply by the conjugate on the top and bottom of the fraction in order to get rid of the fraction. Right? So the conjugate down here is 1 plus sine of x. So we're going to multiply by 1 plus sine of x. Okay, and the idea here is to make, we talked about the strategies before, the things that you could try to do back here on this first slide. This one is where we're trying to create a monomial denominator. Okay, we're trying to make the denominator of this fraction just one term, because right now it's 2 terms. So this is a way to do that a lot of times, multiplying by the conjugate. So whenever I multiply the top, of course I've got cosine x times 1 is going to be cosine x, and then cosine x times sine x. And on the bottom, 1 times 1 is 1, and sine times minus sine is minus sine squared x. All right, but then 1 minus sine squared, using the Pythagorean identity, 1 minus sine squared is cosine squared x. So up top I've got cosine x plus cosine x sine x. All right. So now at this point, what I can do is split up the fraction and do cosine over cosine squared and cosine x sine x over cosine squared. So I'm going to say, all right, put the cosine of x over cosine squared of x, and I've got cosine of x sine of x over cosine squared of x. Okay, so this is essentially, splitting the fraction up. Instead of normally, we would add the fractions together with a common denominator. Well, now we've got 2 parts up top with a common denominator, so we give them their own denominator so that we have 2 different fractions, because we know over here on the left side we've got 2 different terms, so we need 2 different terms now. Now we're trying to go from 1 fraction into 2 different terms. All right, so to do that, you got to make one denominator, one monomial denominator. All right, so that's why we multiplied by the conjugate, was to try to get a monomial denominator. Once we do that, now we can split it into those 2 different parts. All right, so now cosine over cosine squared. Well, one of those cosines on top, or one of the cosines on bottom, is going to cancel with the cosine up top. So that's just going to leave 1 over cosine x. Right? You got one of them up top, you got cosine times cosine on the bottom. So cosine cancels with one of them, so it's just 1 over cosine. And then over here, the cosine up top is going to cancel with one of the cosines on the bottom. So you're just left with sine up top, and then 1 cosine of x on the bottom. All right. Now we use our reciprocal identity to change 1 over cosine into secant, and we use the quotient identity that sine over cosine is tangent. So now we can show our identity is true. We've got secant x, little screw up there, secant of x plus tangent of x equals secant of x plus tangent of x. Yeah, be careful when you're writing secants of x. Make sure you put that c in there. You're gonna, get something that probably don't need to be talking about in math class. All right, so let's move on and try the one down here at the bottom. All right, so this one's a little bit, it's complicated. You got 2 fractions, so you've got to try to use your identities to make the denominator of one look like the denominator of the other, and vice versa. So I would probably start with the left side and see if you can use a conjugate to change the denominator into something you can work with better. So I told you wrong on the first step right here a minute ago, so sorry if you tried the denominator multiplied by the conjugate. This one you're actually going to use the identity for the Pythagorean identity, because we see this is cosecant on the bottom, but this is cotangent squared. So we need to try to get those to be the same trig function. So we're going to use the Pythagorean identity that cotangent squared is equal to cosecant squared minus 1. So we'll change cotangent squared up top to cosecant squared of theta minus 1. Then on the bottom, we've got 1 plus cosecant of theta. All right, so then from there, we're going to factor. Okay, and I know you're like, well, how do you know to factor? Well, the only clue to know to factor is that you see 1 plus cosecant theta on the bottom, and up here you've got cosecant squared theta minus 1, which is a difference of squares. So that's a difference of squares, and if you recognize that as a difference of squares, you'll know that when we factor it, we will get 1 plus cosecant theta as one of our factors. So I'm going to factor the numerator. I'm squaring cosecant theta, and I'm squaring 1. So I'm going to do cosecant theta plus 1 and cosecant theta minus 1. Then the bottom, of course, I have 1 plus cosecant theta. And then the cosecant theta is 1 plus cosecant theta and cosecant theta plus 1. They're the same thing. So those are just going to cancel each other out. So I'm left with cosecant of theta minus 1. Right, now, let's try to work with the right side of the function to make it look like what we've got on the left side. All right, so what we can do is split it into 2 fractions, because if we want to make it look like cosecant theta minus 1, we need two different parts. We need two different terms. So let's take the right side and split it into two fractions. 1 over sine theta minus sine theta over sine theta. All right, so now we've got two parts. Now let's use our fractions, our knowledge of reciprocal identities and all that stuff. 1 over sine theta is cosecant theta, and sine divided by sine is 1. So now we've got the two sides equal, all right, and we show that the identity is true. Okay, so sometimes you've got to, work with one side to simplify it down, and then work with the other side if both sides are kind of complicated. So it's not always just do everything to one side and make it look like the other one. You just got to start with the most complicated side, and then if they're both kind of complicated, you got to simplify both of them sometimes, and in order to verify your identity. All right, so let's do a couple more, and we'll be done. All right, so right here we can change the right side into the left side. First of all, notice they both have a tangent squared x, so let's factor that out. Tangent squared x, that leaves secant squared x minus 1. All right, then using a Pythagorean identity, we know that secant squared minus 1 is tangent squared. So I'm going to have tangent squared x times tangent squared x, and tangent squared x times tangent squared x is tangent to the fourth of x. So now I've confirmed that my right side is the same as my left side. All right, then on B part, you've got sine cubed times cosine of the fourth equals sine squared cosine of the fourth times sine x. So, So what we can do is take the right side and factor out a cosine to the fourth, because they've got cosine of the fourth minus cosine of the sixth. So let's factor out a cosine to the fourth x. That's going to leave 1 minus cosine squared x. And then, of course, you still got your sine x left over out here. Right? So we just took four of the cosines away from those two terms in parentheses. That leaves 1 minus cosine squared. So we know that 1 minus cosine squared is the same thing as sine squared using Pythagorean identity. Now you can multiply sine times sine squared, and you get sine cubed x times cosine to the fourth x. And that equals the left side, sine cubed x cosine to the fourth x. So we got that one done. All right, so some of these are a little bit simpler. They're not always real complicated. You guys try this one down here, and I'll go over it, and we'll be done. So on the right side, in the parentheses, we notice that cotangent, cotangent cubed have a cotangent common. So we factored out a cotangent of x from the parentheses, wrote it right here next to the cosecant squared, and then that left in parentheses, 1 plus cotangent squared. Then using a Pythagorean identity, we know 1 plus cotangent squared is cosecant squared. So I changed that to cosecant squared, and now we're multiplying all those, so I can multiply my cosecant squared and cosecant squared to get cosecant to the fourth x times the cotangent x, and we've shown that the right side and left side are equal. All right, so again, follow these steps and look for opportunities to use, to add fractions or to factor an expression, square binomial. Look at what you're trying to change to. It's a hint as to what to do sometimes. So, for example, the thing on the right side. Well, you see on number B right here, we've got two fractions, and on the left, it's just one thing. So that's a clue. We need to try to add those fractions together. All right, over here, you've got, these are pretty straightforward, but when you see, tangent squared plus 1 and cosecant squared minus 1, you got some trig function squared with a 1. That's a good hint to use, that you're going to have to manipulate and use one of your Pythagorean identities. All right, so you start seeing those squares. Okay, right here, you see on the left side, you've got two terms, but on the right side, you've got one fraction. So that's a clue that you need to change that fraction into two terms. In order to do that, you have to have a monomial denominator. Okay, that means one term in the denominator. Well, since we have two terms, we need to multiply by the conjugate in order to get something we can change into a monomial denominator using an identity. So when we do that, we get 1 minus sine squared x, and we're like, oh, well, that's an identity. We can just change that into cosine squared. So now we have a monomial denominator, and we can split it up into multiple terms and then simplify from there using our other identities. So just use those clues based off what you're given to help you figure out what to do. Let me know if you have questions. Let's go and practice those problems on the front slide.